Okay, so this beginning part, we're just going to talk about negatives because negatives can get a little dicey. When you see negative 5 to the 4th, that means how many negative 5s are multiplying together? 4 of them. So if I take 4 negatives and multiply them together, what is it going to turn into? A positive, because for every 2 negatives it makes a positive. So what's negative 5 to the 4th? Positives is a 625.
It should be 625.
So then underneath it, if you have positive 5 to the 4th, if I have 4 positive 5s multiplying together, what's my answer going to be? Same thing, 625. So there's something different that's kind of happening here, and it has to deal with like just a slight definition that we're going to talk about. And it has to deal with the 4th root of 625. If you use your yellow sheet, what's the 4th root of 625? 5. Because 5 times 5 times 5 times 5 is 625. What other number times itself 4 times is also 625? Negative 5. So, it has been brought up, people have been asking, like, why don't we have to do the plus minus? So the idea of you introducing a plus minus is when you're solving an equation. That's where we've seen it as, is we're solving an equation, we take a square root, we do plus minus. There is something called a principal root. Principal roots are what I myself am concerned with. It just means the main answer. It's like the square root of 25, we say 5. We also know negative 5 is an answer because 2 negatives make a positive. The reason I'm mentioning this is you guys might notice, like on a worksheet, on the ACT, something like that, if it ever says like all solutions, then technically 4th roots and square roots can be positive or negative. Because if you have an even amount of negatives, it makes your answer it makes your answer positive. So just a heads up, technically these are plus minuses, but we're not going to worry about that. I'm looking for the principal answer, unless you randomly see like all solutions, like you're taking the ACT and there's a multiple choice and they have a negative. Negatives can happen. Along that same line, can we take the 4th root of negative 625?
No.
No, there is no way that you can have 4 numbers that are the same and have it be this. So we are going to say it is no real solution. And then this is also kind of popped up. We're dealing with real numbers. So no i's, nothing weird. We want to be able to actually take the answer. Some people have been taking that negative out and making it an I. An I only comes from the square root of negative 1. So like negatives don't come out of 4th roots and become an I. That's something different. So if you have a negative underneath an even root, so either a square root or a 4th root, we're not even going to mess with that. We just put no real solution. Like we are not dealing with anything imaginary. So if you have an even index, if whatever you have on the inside is positive, technically your answer is positive and negative. Because a whole bunch of positives is a positive, an even amount of negatives is still a positive. If what's underneath is a negative, no real solution. We are not doing anything with i's in this unit. We're not doing anything imaginary. If you are asked to take the square root or a 4th root of a negative number, you just write no solution. We are not dealing with i's in this unit because we're going to be graphing in our next lesson, and that doesn't like go well with graphing. If we flip it and now it's negative 5 to the 3rd, how many of these negative 5s do we have? 3. So if I have 3 negatives multiplying together, what's my answer going to be? Negative. So an odd amount of negatives makes your answer negative. Underneath it, 5 to the 3rd, if I have an odd amount of positives, what's my answer going to be? Positive. So the fact that negatives, when taken to an exponent, if it is an odd exponent, it gives you a negative answer. What that translates to is if we use that same idea for the roots. What's the 3rd root of 125? 5, because it's 5 3 times. Now what number times itself 3 times would be negative 125? Negative 5. So if you have an odd index, so a 3rd root or a 5th root, the negative can come out, because if you have an odd amount of negatives, your answer is negative. So odd indexes are kind of nice because if the inside is positive, your answer is positive. If the inside is negative, your answer is negative. Important thing in all of this, if you have a negative and it's in an even index, don't mess with it, just leave it as it is. If it's in an odd index, it can come out. So negatives can come out. Not a huge deal, but kind of just a little technicality. Main thing is a negative underneath a third root or a fifth root can just follow out. Okay, the actual lesson for today is rational exponents. What word does rational start with? Ratio. Ratios are fractions. So anytime you see rational in math, it just means you have a fraction. There's a rule here. There's a pattern that's going to exist. So we're going to have exponents that are fractions. Radicals and exponents work together. Just like multiplying and dividing, you can kind of think of them as the same thing, like divide by 2 times by a half. When we see an exponent and a radical, they can be written in either way. So a to a fractional exponent, the bottom number tells you what sort of root you're taking. The top number is the power that it's being taken to. So when you see a fractional exponent, what it's really telling you is a power and a radical at the same time. One different notation, do you see how underneath it now the m's on the inside? That power is the same thing whether it's inside the radical or outside the radical. I prefer to have it outside the radical, and once you start seeing examples, you'll kind of be like, oh yeah, that makes it a little bit easier. But what we're going to do today is just practice how without a calculator can you find answers of fractional exponents. And the key thing is going to be the yellow sheet. We are not going through the examples in order, so just kind of like follow my lead as we jump around on these. Starting with number 2. So orders of operations, this is saying do parentheses first. So what's the fourth root of 16? So look on your yellow sheet. What's the fourth root of 16? 2. I have not taken that exponent yet, so I'm just going to put that back. Now, using your yellow sheet, what's 2 to the 5th?
32.
Done. Number 3 now. Now do you see how that exponent is underneath the radical? So technically, we should do that exponent first. But is 1,000 squared going to be a big number or a small number? A really big number. So this is the same thing as saying the third root of 1,000 squared. So your power can either be inside the radical or it can be outside the radical. I like to do it outside the radical because on your yellow sheet, what's the third root of 1,000? 10. I haven't done the exponent yet. What's 10 squared? All right, now number 4. Now we have a fractional exponent. So when you see this fractional exponent, there's 2 pieces of information. The bottom number tells you what type of radical. So a 2 means it's a square root. The top number is the power. So what's the square root of 25?
5.
What is 5 to the first power?
5.
So as we do these, this is what I expect to see. When you guys take your assessment next week, literally like a couple points. One is for just rewriting it, and then for the answer. So if you are like, I'm just going to punch these into my calculator, I'm looking for the pattern. Number 1, what type of radical are we being asked to use? Bottom number, so 64, the third root of it. What exponent then? 2. So yellow sheet, what's the third root of 64?
4.
Haven't done the exponent yet. What's 4 squared?
16.
Number 6. What sort of radical are we being asked to find?
The root of 5.
Fifth root.
The fifth root of 32.
And then what exponent? 3. So that pattern never changes. Bottom number is your root, top number is your power. What's the fifth root of 32?
2.
And now what's 2 to the third?
8.
Number 8. What sort of radical are we being asked to find?
fourth root of 6,561.
And then what power on it?
The third.
The third. So bottom number is your root. Top number is your power. I like doing the root first because it makes it smaller. So what's the fourth root of
9.
that big number?
9.
9. And then yellow sheet, 9 to the third.
79.
Question so far?
Nope.
Okay, number 5. What sort of root are we being asked to take? Third root.
Third root of -8.
What power?
1.
So once you rewrite it that way, it should just be like bopping around the yellow sheet. Negatives, be careful. What's the third root of -8?
-2.
-2. Negatives can come out of third roots. What's -2 to the first power?
-2.
Right underneath it. What sort of root? What power then? What's the third root of -512?
-8.
-8. So again, negatives can come out. And then be careful here. Negatives, just be careful. -8 squared. So -8 times -8.
64 positive.
So when you have negatives, just take a second. Like, if it's an even, it's probably going to go away. If it's an odd, it's probably going to stay. So just be careful about that kind of stuff. Number 9. The thing that's nice and not so nice about these is everything you guys already know still matters. So if we have a negative exponent,
Gotta put it up.
yeah, it's going to make it into a fraction. So this negative right here literally just means it's on the bottom.
But then, what is that? 2 term negative?
And now we have, nope, so when you take away your negative exponent, whole thing goes to the bottom, not negative anymore, and then you kind of just proceed on. So what type of radical are we being asked to do?
Over 1 on top.
What's our bottom number? So it's a square root of 100. What power?
3.
So the fact that it was a -3/2 just means we're doing the exact same thing, it's just on the bottom. What's the square root of 100? What's 10 to the third?
1,000.
So our final answer is just 1 over 1,000. And now here's the thing. That negative, technically that negative should be dealt with at the beginning, just like we did there. But if you are someone who's going to just look at this and be like, hey, I have a negative exponent, so at the very end, what's it going to turn into?
A negative.
A fraction. So if you have a negative exponent, it's going to turn into a fraction. It doesn't matter if you do it at the beginning or if you just remember to do it at the end. So you could also just look at this and be like, it's a third root of -125. What power does it have? 1. So that negative is just going to make your answer a fraction. So if you just want to like hold on till that to the end, totally good. What's the third root of -125? 5 or -5? -5. What's -5 to the first power? And then since it was a negative, we're just going to make it into a fraction at the end. So the negative exponent makes it into a fraction. If you do it at the beginning or at the end, it's the same thing. Do you guys have any questions on that?